Hello, good afternoon. My name is Caden Stevens. I'm here accompanied by my partners Fabian Enriquez and Pedro Rincon.
Yeah, we're right here. Yeah, I'm Fabian in the blue shirt, and then Pedro Rincon in the hat.
And we
Continue.
don't know how the Zoom recording works, so if you can't see them right now, it's okay. You'll definitely be able to see them at the end of this presentation right here. We want to do our final design review today for the electroencephalogram for our EE449 project. Let's get into it. So on the agenda for this project, we're going to go look at the Gantt chart. We're going to do look at prior design reviews, and this is going to show project progress throughout the quarter. And we're going to look at a final complete circuit schematic, and then we'll get into the complete end-to-end test of the system that Pedro and Fabian will be showcasing for us today. So the Gantt chart. Okay, perfect. This is our beginning Gantt chart starting September 14th of the quarter. It does not show all the progress here. I would have to exit out and go look at the Excel sheet. We've had multiple design reviews, one, two, three, and four. We had a preliminary design review. Went to the process of identifying the key components for this system, procurement of the devices, purchasing the systems, navigating who's going to purchase what, how is this person going to get the materials. We had to navigate through all that, designing LT Spice schematics and simulations, designing the layout, sending the board out to get fabricated at the end, and construction of the base and head unit for this assembly. And I also did a little test plan draft so we could, be prepared on testing day, and of course, testing of the device too as well. Prior to design reviews. So the first design review was the instrumentation amplifier. So this is a 3 op amp, 9-volt power single supply IA. IA. This instrumentation amplifier could be built with either ideal or real op amp models. The amplifier must have a differential gain of 60 dB. Testing this involves using 100 microvolt peak to peak signal, 10 volt at 10 hertz differential voltage input. And then so what was following this was this a continuation of the first kind of requirements, first week's requirements. So we had an improved instrumentation amplifier now with our actual op amps that we would be and the end op amps that we would be using for our circuit. Everything was still functioning too as well here. Okay, design review two was the construction of our bandpass filter using an online filter design program. So bandpass filter with center frequency of 12 hertz and -6 dB passband of 6 hertz. This filter is able to reject 60 hertz noise and reject low frequency EMG signals, which is like muscle signals. It also emits alpha waves between 7 and 12 hertz and beta waves 12 to 30 hertz too as well. Next, we have our optical detector circuit. So we created it in LT Spice in a physical circuit. Don't have a physical picture here, but we do have like the actual 82 um, simulations that we ran for the physical circuit. So uh, this is part of our base unit. The circuitry receives the PWM signal from the head unit and restores it to an analog signal that can be displayed on the 82 oscilloscope. We have the construction of the alpha and beta filters. So again, alpha filters is going to manage that 8 to 12 range, and then beta is going to manage that 13 to 30 hertz range too as well. So kind of just keeping it going here. Uh, Next, we have our complete systems. As you see on the right-hand side, we do have the actual fabricated board from Bay Area Circuits, as well as our base unit. Let's see. Yeah, and this final design review purpose was to demonstrate a complete and functional system. So let's get into the schematic. This is kind of blurry, so I will hop over to LT Spice, and we can kind of just go through everything. This is our IA. This is our reference voltage circuit, PWM circuit right here, the bandpass filter going into our optical detector circuit, and then the alpha and beta circuitry too as well. So we'll go hop back over to this presentation. And now we're going to get into the complete end-to-end system. We constructed, kind of put together, putting the the head unit within an actual hat. And here is Pedro and Fabian working on it, and then Pedro demonstrating it for us right now too as well. And now they're going to get into the actual physical demo of this setup. Thank you.
All right, so we'll take it over from here. So I'm Fabian, the one behind the camera, and here's Pedro, the one with the hat. Here we have the circuit. Here's the base unit right here, and then connected to the hat we have the. Let me see. It's the head unit, and the infrared sensor is right there. If you could see, yeah. So it's right there, and we have the battery on top of the brim of the hat, and then the electrodes are already connected to its head. If you can see it right there. We kind of have it hidden right there. So now Pedro would demonstrate that the circuit is working with the alpha and beta filters. So you want to explain which one is which?
Yeah. So set the camera. That'll be easy.
Yeah, right there. Well, you want me to
There you go. You're good.
like that?
No, the other way.
Oh,
Sorry.
yeah, I had it like that.
Okay. So this is gonna be our alpha right here, and then we have our beta with the red. Our detector is right here, and obviously you saw the emitter in the hat. This is a little tricky to get it working properly because the emitter does have an angle of 45 that you have to deal with, and the receiver an angle of 30 according to the data sheet. So I'll try getting it working. There you have it, sort of.
So it doesn't come out as nicely on the camera, but currently we see that both are on. So around a frequency of 15 hertz. You want to try taking a deep breath?
That's the best I'm gonna do.
Yeah, so that's the best we're gonna be able to do. But they do work, and we'll be able to demonstrate on the oscilloscope. So you want to just reach how far?
Try doing the distance. So that's at the very like touching each other literally.
So that's
and about there I start losing signal.
yeah, because there's also, keep in mind the angle of our sensors. One is at 45, the other is at 30 degrees. So we kind of have to find that sweet spot. But at the moment, so if we could even show you that it does work. So you want to go a little bit closer?
I'll put my hand in
Yeah.
between it. Let's
Put
see.
your hand between.
Covering it, taking it off.
Cover it. So we are transmitting, with signal across our infrared sensor. And then now we'll go over on the oscilloscope. So let me share my screen on my laptop. Here we go. So you want to move closer, Pedro?
See the screen, Pedro?
Can you see the screen?
Yes, I can see the screen.
So the one in yellow, our channel 1 oscilloscope probe is connected to the alpha filter, right?
Yeah.
The output of the alpha filter, and the blue one is connected to the output of the beta filter. So as you can see, the alpha filter is more dominant, so he's more relaxed, but it's still turning both on. And that could be due to the fact of the how we design the alpha filter. The cutoff might not be that steep, so it can bleed over into the beta filter. But as you can see, we have it working and demonstrating.
Yeah, well, obviously, like we have it working as far as transmitting signals goes. Obviously, we could have perfected it even more if we had more time.
Yeah.
But as far as that goes, this is pretty much all we have. At least we have something working properly, transmitting and receiving.
And that is it.
I also just want to add too as well. We did have board manufacturing difficulties, so we did have like little errors on our PCB board. Fabian and Pedro were able to work around these errors, given that they were defective. So we did have to do a little bit of workaround too in that department too as well. And yeah, I'm very proud that we got this working. Everything's good, and maybe we can even submit a follow-up video too as well, if need be, showing the working alpha and beta signals from different brain waves from Pedro here.
All
Yeah.
right, perfect.
Yeah. Thank you, Professor McCarley, for a great quarter. I know Fabian and Pedro are appreciative as well of the
Thank
instruction.
you. All right, thank you.
Thank you.
All right, end it.